So OMFIT has different ways to connect to MDSplus. Here, if we go under the tree edit, we see MDSplus tree. This is a class that allows you to browse an MDSplus tree. So in this example, we're going to access the D3D server. And we're going to connect to the tree name called electrons for this shot. For D3D, we have a list here of what are the available trees. So you see that
how did you get there?
Electrons is here.
How did you get the list?
So the list appears automatically when you use this setup tree entry GUI, and it just shows up. So let me just, so for example, you can see that there is an electron tree, there is an EFIT tree, fluctuations, ions, AOT is auto12, and so on and so forth. And we should also say that the organization of the MDSplus entries changes tokamak from tokamak to tokamak. So if we just hit return, we'll see that in the OMFIT tree we have this test, again, electron shot in machine. And if we expand this, what OMFIT will do is we will query MDSplus to get the tree structure. And so we can see that under the electron tree, there is, for example, data from the Thomson scattering system. Here we see the blast data, for example, the different subsystems. For different subsystems, there is, for example, the measure of the density and so on. These three, for example, and we can access the data in here by pushing a return. So, for example, this tree entry, this MDSplus entry has just a string which says measured density profile. You can hit P, suggested, to get that printed to the console, and this actually works for anything that is in OMFIT. Pressing P will call print on that object. Maybe something more interesting that is under profile fits. ZIPFIT is some profile fitting routine that is run automatically between shots at D3D. Here we can see the density fit and the temperature fit. And again, also in this case, if we hit return, this is some array data. So it's a 2D array. You can see it here. And when we hit return, we can just see it. What we also, so one thing to notice is that in MDSplus, the data is not only stored in the leaves of the tree data structure, but also in the nodes. You may have data also in the nodes. Just keep that in mind. And each entry in MDSplus can have the data, but it can also have dimensions associated with it, as well as errors and units. And so when we actually click return on this entry, what happened is that actually OMFIT not only gathered the data, but also the dimensions, the units, and so on and so forth. And so that's why this graph, for example, knows what are the dimensions in each one of these dimensions. So this is when we operate from the tree. If we want to get the data from the command box, we can copy the location, paste it, and here, if we want to get the data, we have to use the dot data. So here we can put this here, and when we execute it, indeed, the data has the two-dimensional data that we saw before. To get the dimensions, so this is two-dimensional data, so it will have two dimensions, hopefully. We have to use the, actually I can make this bigger like this. We can use the methods dim_of, and then we have to specify the dimensions. So d0 would be one dimension, d1 would be the second dimension. And so here you can see that one d0 is this is the row axis, and d1 is the time axis, which is non-uniform. To get units, so to get the error associated with the data, we can use the error, and these are fits. So probably there is no, there is probably, oh no, there is an error. I wonder what that is. That's a good question. I don't know.
ZIPFIT calculates errors.
Okay, so this is the error associated with it. And so if we look at the range, so this is from 0 to 1, I guess, and this is 0 to 10, so 10% error looks like reasonable. And then other things that we can ask is units. So we know that this is in 10 to the 19. There is also units d0. So I think units dim of 0. Hopefully that works. And units, oops, and it is units d1, and this is milliseconds. Okay. Other useful things that we can do, we can, for example, get an X array from an MDS entry. So if we say X array, and here we say X data, for example, we run it, and now this is an X array with dimension 1 and dimension 0 of the right type. And again, we can also plot this one. And I think this one has actually also uncertainties associated with it. So if we say print x data dot values, let's say the first 10 elements, we can see that these have uncertainties associated with it, which were retrieved with the error. So this is how we use the OMFIT MDS value. One thing to notice is that this class is only the top level class, and everything underneath is of type OMFIT MDS value. So when we want to access something in MDSplus, in OMFIT, we could in principle, so let's say that we want to get the density fits, we could in principle say OMFIT test is equal to, actually, let me copy this, is equal to OMFIT MDS value of this tree name, this shot, this server. And then we can access, we could access the data like that. However, this is quite inefficient because we have to retrieve the information of all of the MDSplus tree, which in some situations can be very onerous. So when we want to access only one item in the tree, and we either know the location or we want to know the location, here if we go under 83 entry again, here you will see that the other way to access this data directly is to use the OMFIT MDS value class directly. In this case, we specify the tree name. The TDI is actually the language that MDSplus uses internally. And this is, for example, a node inside of MDSplus. But then, as with TDI, you can actually perform operations. So you could, write a TDI function that will take the data from two nodes, sum them up, and return that to you. And the difference would be that that operation would be done on the server side. With respect, doing it, for example, inside of OMFIT. And again, the shot, and then the server, and the rest are details. But so if we want to get our MDS, this is NE, for example. If we do this, we can see that we access this data, this entry directly. So if we want to change, for example, shot, this is now, the density value for the density fit for a different shot. And you can also see that things are, OMFIT are loaded only when we request them. So in this case, the data is not being fetched, and when we hit return, the data will be fetched only for that shot. One more thing to maybe point out for MDSplus, if you look at under the regression scripts, there is a capital MDS, probably test MDS. And in this regression script, you can, I think it's a good summary of the MDSplus servers that we know at least can work with OMFIT. And so we can see that there is D3D and STX, transp for TFTR or JET or any other device. JET can have different ways to access its data, because they can use the MDSplus in its proper way, or they can use this MDSplus to read these files that they have JET PPFs. So they would use an MDSplus to read those PPF files. Alcator, East, and TCB. Let's see. Any other things to point out? We can also use MDSplus to OMFIT MDSValue to write some data in to MDSplus. The way this is done is like so. So first we have to create an MDSplus value. Sorry, yeah, an MDSValue. And then we can write data if this data is set as an X array. So the choice was to, because fundamentally X array and MDSplus are kind of similar in the sense that they both want to have the data. They both want to know the dimensions, the units, and so on. The choice was to for this write method of the MDSplus value class to accept an X array, so that we know that what you're putting in is consistent. Anything else, Sterling, that you think we should cover for MDSplus?
I think it covers the basics.
Right. And I should also mention that MDSplus in OMFIT has different levels of caching. So in fact, if we try to access the same data twice, for example, here I requeried the same data again, and we see that the data doesn't need to be refetched, but it's already available there. And that cache is actually stored under Scratch MDSValue cache. And so this is what contains the data that we queried. Okay. So maybe switching gear to the relational databases. What do you think? Yeah.
Okay.
Do you want to take it?
Sure.
All right.
Okay, so I've loaded up some scripts here on Iris. I've used the test OMFITRDB regression script and just copied its contents over here to the.
What does RDB stand for?
It stands for Relational Database. A relational database just is a fancy way of saying we have a whole bunch of tables of data, and in those tables of data we have columns of data, columns being classifiers of whatever type, and then each row is an entry in the database. I guess it would be useful to start out by talking about how to find out what the tables are in the 3D relational database. So there's a website here you can go to, and you can select which database you want to look at. For instance, plasmas.
D3DRDB, right?
Mm-hmm. D3DRDB. Yes, as the database name.
And actually, that's the database on D3D that contains most of the tables that are of interest for a physicist.
Yes. Well, there is also the code run database.
Right.
But yeah, somewhere between those two. So then that gives you a listing of all of the tables from which you can gather data. And these tables can be linked so that as you pick out a row in one table corresponds to a row in another table or multiple rows. So that's the relational part of relational database, is the fact that all these tables can have a relation to each other. So good.
I think, for example, the summary table could be interesting.
Mm-hmm.
So this is, for example, a table that summarizes any D3D shot that gets taken. So this says this table has a whole bunch of scalars that are automatically filled in after each D3D shot is taken. So, for example, if you want to select all of the D3D shots within the last year that had a pulse length of at least 3 seconds, this is what relational databases are extremely good at. If you wanted to do the same, with MDSplus, you would have to traverse, to go through every shot and look at, the time dimension of one signal to figure that one out.
Right.
That's just because MDSplus can't append, like it can't just have a running.
It's just how it's designed.
Pulse length doesn't seem like versus shot number doesn't seem like a hard thing for MDSplus to handle.
Well, it's just the
scalars. It shows.
It's just how it's designed. So MDSplus is really designed to look at things by shot. So whenever you want to do an operation that goes across shots, it becomes very cumbersome very quickly. Basically, you would have to do that with a for loop, or you can do a fancy for loop and do it in parallel. But it's effectively you have to touch all the data.
Yes, and so there's this fundamental not disagreement, but dichotomy between MDSplus and relational database, because relational database is very good at doing one thing, and MDSplus is good at doing the other one. And based on what you're doing affects the way that you really should be fetching the data, and be nice in a lot of instances if you could represent the data in both ways simultaneously.
Mm-hmm.
So I loaded up this test OMFITRDB, copied the lines that are relevant to the Osborne tools. And so, for instance, I'm just calling here OMFITRDB. I'm selecting star from profile runs. That's the table where he keeps all of his parameters that are used to run his profile fitting tools. Some where statement. And this is just general SQL statements. You can search the web for SQL statements and how to use them. And setting my database to D3D for connecting to his server, which is Fues. And so you can see here in the tree what that produces. That produces the rows, and in each row there are 237 columns. These are each of the individual settings that you can set to run his profile fitting tool. And okay, so you can see how that would be useful for looking at individual rows of the table. It's also possible by giving the by column. Where are we? Osborne column here. So by column equals true, and then instead of going and listing all the rows, then we can list all of the entries in the row. And so then we get something like complete, which is now an array where each row becomes an element of the array.
It's basically looking at an Excel spreadsheet, where you're looking at one row and all the columns, or looking at one columns and all the rows that it's a transpose. It's fundamentally a transpose, and depending on the operations that you want to do, you may want to set that attribute by column to true or not.
Right. And so I went and looked. So when you do by column, if the data is missing for that row, then we go and fill it in with a none. And so that's how you end up with objects here, object arrays as opposed to some type of string or otherwise. So something I just noticed was that if I looked at this other table, the ped scale table, it had some quantities in it that looked like a bunch of tuples. And so there remains to be some work done here to translate those tuples. That's really nominal value and uncertainty.
Oh.
And so anyway, if you come across that and looking through his table, that's what that is. Then let me pull up let me just run this test here. And when we access the tables, you can also write new rows. I don't think you could add new columns, but yeah, so that's an option. So here, this D3D-RDB was selecting star from summaries, which we looked at, where shot was something, and the IP flat top was greater than 800 kilowatts. And so you could see, the time of shot, the pulse length, etc. And so we just selected star from there. And if you wanted just something more specific, you could, instead of selecting star, you could just select shot. And then these are dynamically loaded, so then load, then you only get the shot out of it.
So one applications, for example, of this was I think Brian wanted to have all the shots in a run day.
Yeah.
And that's, for example, something that would be stored in the relational database.
Yeah, it's very useful that way you don't have to keep typing in the next shot number as you're running an experiment.
Mm-hmm. You
just say this run day, and it gets the shot,
right,
and remake your plot.
Or if you want to know what shots succeeded versus which ones were disruptions.
Right. We also use it when we're looking at the EFITs. If you want to go and grab a snap file, then it goes and queries the database to find out which EFITs have already been run.
Right.
To be able to grab their snap file.
So right, if you go maybe to the web again, there is the other table that you were mentioning, the code run. If you just go back, yeah. Code run DB, yeah. So some codes at D3D, once they are run, they will put in an entry in this table. And so, for example, EFIT is one of those, and 1.2 is another. Transp used to be, but we should. That's not the case anymore, and we should actually fix that.
Yeah, that's true. It will be the case.
And my understanding is that this plasmas table is the one into which all codes should write, when they've run something.
Oh, I see.
And then if there's further details that don't fit into these parameters, then we could request a separate table.
Okay. Do you want to? We have a half an hour. Maybe wrap it up here. I think Catherine, half an hour, right?
Yep.
Okay. Maybe just to mention that if for people who are interested in Tom's, the data that is in Tom's databases, there is a Osborne.
I'll just give a quick flavor of that here.
Oh, okay. You have it. Shared.
Yeah.
You have it already loaded.
So this is just copying out of again, another regression script, the test Osborne MDS script, and that just goes and fetches this particular run from run that Shi Chen had done. You can see here that on the server D3D tree name pedestal, this is within OMFIT Osborne profile class, and that shot and that time and that run ID. You can see here, it just plot. You can plot all the fits that are stored there, and that's shown here, and that automatically overfits the data, overplots the data. You can get the fits or plot all the fits with the derivative, and so here it's showing the derivative with uncertainties. So there's that class that's very useful for interfacing with results that have been run with Tom's tools and then stored in MDSplus.
Okay, Catherine, do you want to take it away?
Okay. Okay, so I'm going to be showing some of the modules and some of the components of the scope module. So I'm on unstable, and I'm going to do a fresh import of the scope module. So there are 3 different workflows in the scope module. The default is the scope signal here, but that's not what I'm going to be talking today. I'm going to be talking about the 2 other workflows, and I'll start out with the Pubfig publications figure. So I really like this module. It's really nice if you need to make a plot in like 2 minutes and you want it to look decent. It does a really nice job here, and you don't want to remember all the different Python commands you want to do. So I'm going to start with looking at this one shot, 165037, and then I'm going to look at 2 signals. I'll look at IP and then BetaN.
Actually, yeah, go ahead.
Yeah. And so one thing
Maybe, while you're talking about signals, can you hit return, that way that goes in, and can you click on that open signal search? This is actually a connection to a relational database where if we say name contains beta, sure, and then we say search. So this one will tell us all of the signals, all of the MDSplus signals that we can that are available in E3D that have beta. And so if there is either through the name or the units or the description, we can often narrow it down or find something that we want. So yeah, I just want to say for the people like me who are not too familiar with the MDSplus tags.
Awesome. So we have our shot selected, we have our signal selected. One thing, if like me, you forget what the format of these are, there are sample formats on the side here. So now we're just gonna, I'm just gonna start out by pressing plot, see what it starts out with to look like. Okay, so you can see here is the default plotting, and if you were in a real rush and had a presentation you needed to go to immediately, this is a decent way to start out with. But if let's say, but if you want to, tune it up a little bit and impress people with how good your coding skills are, this will help you do so. So let's go through each of the different options we have here. So this is good for both papers and presentations. And one of the differences between papers and presentations is papers, you want to have like figure captions like A, B, C, D. But like, let's say this is going to be for a presentation and you don't want that. You can turn off the A, B, C, and then we'll see that this A and the B that we have here is not going to show up again. Then we can adjust the line thickness and then the scale. So on the top here, we plotted IP. And so you can see IP is stored in amps, and you don't usually want that. Usually you want to store it put in mega amps. So let's change the scale to mega amps. And then the color is blue. I don't really like the color blue, so I'm going to change it to black. And then let's go to the label. So the label is just IP there, and it looks okay, but we can actually make it look a little bit bigger, so look a little bit better. So let's use latex to improve how it looks. So we're going to just say IP mega amps. Now let's go look at BetaN. So BetaN, let's again change the color. Let's go to red because it's my favorite color. And then let's change the label here. So again, we're going to use latex, and we're actually going to get the Greek beta symbol here. So now let's plot this and see what we have, not what these changes we've made. You see with just a few button presses, this already looks a lot better. But now let's say you want to tune it up even more. Let's keep going through the tabs that we have here first. The first one we have is A, so this one you can set tick locations and YLM. Python drives me crazy with its tick locations for BetaN. I don't know why it's every 0.8. So let's go to the B and go to and just make it some logical numbers, 1, 2, 3, 4. And then let's go to the appearance tab. So the appearance tab is where you can also change some other things. Like, I think this is maybe a little bit too wide of a figure size. So instead of it having be a width of 10 and a height of 9, let's change this to be 8. Now, there are some other things that you can change. You can change the font style. This is big by default. There's this J standard, but you can press the button here, and then you can manually set all the different font sizes that you probably didn't want to know that each one has a different font family, but it's here. And then same thing with axes, you can change the tick width and the tick length and the axis thickness so that they all match together. Now there is also the capability if you want to show vertical lines and horizontal lines, vertical shading and horizontal shading. But let's stick with the changes that we've made so far. I pressed what did I do?
You put the Y limit as the tick location.
Oh yeah, I do that all the time actually. Okay. I've done this one before.
YLM 0, 0.
That's okay, but
It's the
it's auto
default.
scale.
That's the default. Okay. So one thing that's helpful usually if you make mistakes like that, it tells you what the problem is. So now we can see here it's not as thick, not as wide. You can see that our Y ticks are what we want them to be. Now let's go back to the appearance. So, and let's change the layout. So currently we have 2 rows, 1 column. Let's reverse it. Let's do 2 rows, 2 columns, 1 row. Let's make it a little bit wider and not as tall. So this would be if you wanted a different format. So you can see here's how this came out. You can play with the settings some more to get it to be what you want it to be. One thing that's also helpful here is you see all these annotations like IP and BetaN. You can actually drag them around if you don't like their initial placement. If you want the shot number to come down, there are some sprucing that you can do in these figures.
Can you also show, can you click on the button on the left of the save?
Okay, so I use this one a lot too. Like, so you can see that our bottom is cut off a little bit. We maybe want a little bit more room to show the time.
Would that be a bug that time is not showing on the left?
That is, that time is not showing. But if you wanted to have a figure that you can have in a presentation for, say, some manager comes to your office and says they need a figure right now, this is something that you can easily make in 5 minutes.
And
you
not
can-
spend time in Illustrator.
Yes, that's a really nice thing that you can do.
So can you add a horizontal line for the BetaN plot at 3.5?
Sure. Let's do that. So you want to do horizontal line at 3.5. I think this will do it to both of them, but I guess it won't show up in the IP one.
Mm,
Oh, good.
yeah. Well, yeah, you can rescale it. But it defaults to all of them, but you can make it a list.
Oh,
Where
yeah,
it's
yeah, I
a
forgot
list
about
where the
that.
first one's empty and the second one's a number, and then we'll put it on the second. There's a click on the help button actually under vertical lines. All plus one time, all plus multiple times, 2 panels 2 different times, 2 panels multiple different times.
So if we want, I guess we would do 0
Lists
for
are
the
easy.
first one.
So this is Darren. I had a question. This is great. So I noticed that you have the GA standard, and maybe you didn't make this decision, but the GA standard font is not actually the GA standard font, because they normally use Helvetica narrow bold, which I think this is just Helvetica bold.
Yes. Yeah. It's as close as we could reasonably get
Wow,
with
good
the
eye.
pre-installed font package.
Yeah, Helvetica narrow bold is better because you can get a lot more. Your fonts don't take up that much width that way, and you can have more space for your graph.
I agree.
Well,
we
we
got
can-
frustrated.
We can easily install that if it's available.
It needs to be installed on the machine.
No, I mean we can just add it to the OMFIT source,
It's a good idea.
and then Macrolib can pick it up.
Nah, Helvetica is under copyright.
Yeah.
Yeah, it's copyrighted.
Yeah. This is the
And
closest. we could-
GA always chooses the most expensive option.
I see.
It's as close to what you would want to show in a presentation according to standard GA practices in terms of thickness, font size, viewability, line thickness.
Yeah, it's
Note
kind
that
of,
OMFIT is more than just GA as well, and
Yes.
so you're welcome to change your font to something a little bit more modern.
Yeah, we welcome any new font classes. Just not Comic
I
Sans.
won't go through.
Yeah.
Okay.
I think that is an option.
So now one thing that happens when you're making plots is you end up with a lot of figures. And so there is this nice convenient close all, which OMFIT automatically does to just get rid of everything.
Yeah.
And so the other capability I want to show is first, I want to go to a second figure. And I want to look at 2 different things. I want to look at the beam power and the torque.
Yeah, that's really nice because if you want to make the same plot for
I'm getting there. Don't get ahead of me.
all right.
What the heck happened? Did I break something?
It's just a high point density. Maybe.
Maybe it's that. So on the left is power and the right is torque. And so one thing when we look at the beam power and the torque, we see that there's a lot of samples here, and it's not something that you necessarily want to show in a publication figure. So we have the capability in here to smooth it. I'm going to put the smooth to be 100 on both of these. And the key thing when you're doing this is you also usually want to disable this overplot raw button unless you want to take a while for your figure to show up, because there's a lot of points when
You
you
should
have
demo
this.
it for one of them because it's transparent, semi-transparent.
Fine, I'll do that for the torque. And
It's truth in advertising.
then let's go back to the power. So we see we have it in units of kilowatts, and so we want to change it to megawatts. So we're going to do 1e minus 3 here. And then we can do the same thing of changing the font label. I can never remember what the units are, and so I always have to open up the plot to figure it out.
So
So you see it took a while, but power is on the left, and then torque is on the right, and then you can see that there's the raw data behind, and then there's the smooth data on top of this. So the other feature that we can have that's really nice if you want to put this figures on the same plot is you can actually do that, but instead of having quotes around each one, you just have quotes around what you want to be in the same window. So we're going to do that here, the same window, but then we're going to change the color of torque. Like the maroon font color, so we're going to go with that one.
Magenta.
Magenta. Right, magenta and maroon are kind of the same.
B is not burgundy.
Okay. So you can see that they're on the same plot here. So this is really helpful if you want to have the ECH power and the beam power on the same plot. You can do this, just make sure that they're scaled right, and then you can move around the labels, and then it works well.
Mm-hmm.
So here we've been looking at just one shot, and I also want to show that you can go do more than one shot. We're going to go back to our first figure that we had, just with the IP and BetaN settings. And remember everything that we had here. As a reminder, here's what our plot looked like. So this is really helpful if you like make a plot and want to come back to it and you realize you accidentally didn't change one little thing. You don't have to start over. It stays here. But what we're going to do here...
Is it saved when you save your project?
Yeah.
So it's not saved in Scratch. Those settings.
No.
Good.
You can browse it under Scope.
Yeah, Scope.
Pubfig. It has current figure and then all the save figures.
Yeah. So there's... Okay, and you can see we have the active, which is the one you're currently on, and then figure 1 and figure 2.
Can you expand those?
So it has all the different settings of the shots, your axes, your font settings.
Are you putting these in? Is that an OMFIT tree?
Yeah.
Yes.
So what if you want to make a really complicated plot like we always do in Review Plus? It has like, 10 rows and 3 columns or something.
It's not a problem. I mean, just make sure that it fits on your window.
This would be something that perhaps you wouldn't do with the Pubfig workflow here. That's more something that you would do with the SCOPE workflow that Kathleen skipped at the beginning, but it's okay. And maybe we can just have a quick snapshot of that later.
Yeah, the goal was to be like most publication figures aren't 10 by 8 panels. Usually it's like you have an overlay of 2 or 3, no more than 3 shots, no more than 4, maybe 6 panels at the most. It's unusual to see a full wide figure. But this is very useful for like the meetings after the experiment, that morning 8:05 meeting. Make pretty much all the figures scarce. So that way, when you screen grab it because you're exhausted, you just want to put them in the slide.
You don't have to screen grab it, right?
Well, you have
can
to send it.
Send it by email.
You send it by email.
Yeah.
But when you produce the figure, you can actually read it.
So I want to show what happens when we have more than one shot here. So when you do that, you see that down below we get a different panel. We have shot settings, and so instead of coloring by the different signals, we're going to color it by the shot. So we have blue and green, and I'm going to switch it to blue and black. I'm going to make one a dashed line, and then we're going to see what it looks like. So you see it the same IP, but different BetaNs. So you can play with these settings to make the figures that you want to. There's a lot here. There's always room for more improvement, but we're also open to suggestions on how to make it even better.
Mm-hmm. One of the things that you can't do right now is mathematical operations by combining signals that are on, for example, different time bases.
You can or you can't?
You cannot. Not here.
Mm-hmm.
That's one thing that's been suggested.
Yeah, and also being able to look at trans data in here would be really
nice.
Right
now it's MDSplus.
Yeah.
Well, it's not. So the trans stores in MDSplus.
Right.
But what you want is basically you can only type tags I
Correct.
guess. You cannot type full paths.
And you probably don't want to remember the full paths. So no one remembers them.
Mm-hmm.
And does it dump an HDF5 file for us for the data management plan?
So one thing I should have shown when we were here. So the way I usually do this is there's a save button here, but there's also this email button, Darren. And so I email myself like the figure like 10 times until I can get, because I usually inevitably put it in my presentation, go, oh, it's the wrong size. I need to change the size, or oh, I forgot to label something. So you can hit the send email button. And you see here it's the PDF and the HDF.
That's quite awesome. Yeah.
So this is really nice. It also if you do the save, it's the HDF5 is saved there too. But I know I recently did for the data management plan, I had a bunch of my figures in OMFIT, and it was just like, just sent it a couple times and had everything. It was really convenient.
Yeah, that's great.
So do we want to talk about the scope part of the scope module?
Yeah, I mean, you can quickly see it. So here, the idea is kind of similar. You can type in your signals. So yeah, go ahead, type IP BetaN. Well, no, IP return. Yeah, and then you can add BetaN.
It's also a
banana.
drop down. So one of the features is that it has a drop downs for, human readable names.
Yeah, for many, or for some of the most common, signals. So you can pick maybe Toledo field. Okay, and then if you hit plot. So this will do like this, and it has the little cursor if you go across with the, So this is kind of a more, review class, I think, approach. If you close this, can you hit, close this figure. If you go to manage, you can say restore or review group. And then under signals, you'll see that there is a whole bunch of signals that, are preset, and maybe under advanced, you can maybe change the number of columns to 2. And that's it. Just plot, and this will kind of give you an overview for the shot. And this was written by a theorist, so I'm sure that there is better signals that one could pick. And but if you make the figure big, you can kind of see what happens in the shot. So I think something like this, it is complementary to what Pubfig does. Mm-hmm. Well, and maybe just to remind people, if you middle click on any of these, right, you can zoom on the plot, right? Mm-hmm. So, and middle click again, and this is true for any figure in so it mimics what the
Pro tips.
GA. Yeah.
There's other things there. So if you go into there in the profiles, what Orson was showing before with ZIPFIT, if you go under presets, you'll see like plot profiles, for example. And there'll be a tab each of all the different plasma profile resolution. Mm-hmm. There's also all the heating and confinement related variables there, which is also a preset.
And also one thing that I use is, if you close this, there is, I think, session leader logbook entries. So this is for that day, what the session leader wrote. Mm-hmm. And I'm sure that there are a lot more comments and people writing in the logbook, at least this is what.
And this is another example of connecting to the relational database.
Correct. Correct. This is all data that is in the relational database. Do you want to maybe give an overview of the database?
Okay. Yeah.
About 5 minutes.
Yeah, I mean, it's going to take longer than 5 minutes.
We can do. I will run away.
Okay.
Yeah.
Take like 50.
Yeah. Go ahead.
Wrong one. Okay.
So yeah, one thing that's common about the SCOPE module, it all deals with time history, is mostly stored with MDSplus related quantities. So if that's the world that you live in, which most people do, this is a very flexible, powerful package.
So this database creator is really helpful if you're trying to understand, trends in a shot or maybe trends in a run day, what's going on. So first I'm going to start off by just looking at one shot, and then we'll move on to a whole run day later. We're going to look at the same shot we were doing in Pubfig. We got to green, so that means that we had it set up correctly. Now we're going to look at some traces similar to what we were looking at before. Instead, we're going to look at ECH and the beam power. And you scroll down, you see where that the min and max is set to 0 in 6 seconds. And then I'm going to fetch the raw data.
So,
Yeah, go ahead.
Go ahead.
While it's talking.
so one thing that you didn't show is that the next row down says select data source for signals. So here's IP is the first one that's selected, and the source is MDSplus. But under source, this can get data from many different sources. You can get EFIT quantities, ZIPFIT, transp, the Osborne database, or library functions that combine multiple signals. That's one of the things that this does more than just get MDSplus tags, much more.
Now we're going to go to the next tab, which is the slice tab. And so here, the default time-based type is signal. I usually switch this to user. So when you say the time-based type of signal, we had all of our signals that we fetched, the BetaN, IP, the PCH, the PRNJ. We would use one signal to be the time base for all the others. So this would be helpful, for example, if you were looking at CER data and you only had data at certain time points and you want all of your other time points to be on the same time base. That's when you would want to use signal. But I usually like to use the user time-based type, where I can specify, I want you to start at this time, I want you to end this time, I want you to take this big of steps. And so then I'm going to set a global smoothing here. So we're going to use 20 milliseconds, then switch this to a different windowing function. I'm going to use Gaussian. There's a causal, and then we're going to apply this global smoothing. And then, but you may notice that one of the things that we fetched was the PRNJ. One thing we learned from looking at the Pubfig is that this has a lot of time points, so we want to smooth this more, so we're going to smooth that to 100 milliseconds. So now, when I press slice data, that'll be smooth, and then all this data will be fetched on the time spacing that I want.
Small correction. I think the motivation for choosing 100 is physics-based, not number of time points.
This is like slowing down time, kind of time scale for the processing to absorb. You should plot the raw and slice data again, just see what happens.
I meant to show that. Okay, so after you fetch the raw data, you can also look at the raw data here. So we can see IP, BetaN, PNJ, PECH.
And there's a tab for each shot if you had multiple shots.
So if I had multiple shots, we could see each one here, but keeping it simple to start out with. And now if we go to the slice, you can see we can plot the raw slice data here. And so you can see here's in the blue is the overall raw data, and in the green is the different time points that we selected. So one thing that we can do is we have this power just derived a tab, and so we can make our own expressions here. So I want to make an expression for power, since I both power from the beams and power from the ECH. One of the reasons why I plotted this raw data is, again, I can't remember what the units are for all these different quantities. And so I have it on the right so I can look at it. And so you can see here I just put quotes and then I can do addition. So I can say power equals, and then I'm going to say PINJ, Then you divide it by 183. Then we add it with PCCH, which is in watts, so different units, and I'm going to divide it 186. And then I'm going to add this expression to the derived list. And so now this is a potential one to make sure it actually gets calculated. I'm going to put it over here to add. Okay. And now we'll come back to this tab later. But now we've started to look at some of this. So when I'm first looking at data, I always like to go look at the history. This is similar to looking at the.
Just like the
I forgot to select the signal. So plot all. I usually do plot all. And so you can see here is the different IP, the BetaN that we have, PI and J. But now let's look at the power tab here. Now, one thing that I realized that I didn't want to do is we're looking at IP for the entire shot, and rather than saying, well, I want to look between this time and this time, I'm going to go back to the select tab, and then I'm going to say, I only want to, I want to reject IP that is less than 0.8 megaamps. So I'm going to add this similar to what we did for the derived. I'm going to add it here. And now I'm going to go back to the plot tab and plotting the history just to make sure that what I wanted to happen actually did happen. You see, it did happen. I'm only looking at the points that I was interested in. Now there's a histogram tab where you can plot for the shot. See, well, how does the BetaN span out? How does the power span out? This is probably more helpful when you're looking at more than one shot, but it's a feature here nonetheless. And now let's go back to the first tab here, which is the scatter. And this is the one I think is probably the most powerful, where you can start making connections between this variable and this variable. So we're going to make the x be power, and then we're going to plot all the 1D scatters. So here's IP versus power. The one that's probably the most interesting is you see, well, as we put more power in, BetaN went up. There's a pretty high Pearson's R² value, and we can go through and click all of these. Now, if we go to the fit tab, you can also fit this quantity as well. So we're going to say power versus BetaN. So if you're trying to figure out how do these two variables that you think have a link go together, this would be the place to go. So this is all for looking at one shot, but I have another OMFIT experiment open that I've already fetched everything for all the shots during this one day. As you can imagine, this takes a bit of time to do. So we're just gonna, now I've done the exact same workflow that we've done here.
So just go back to the raw tab and show that you entered a run day, right?
Yeah, I did. Okay, so I entered a run day here, and you see when I entered the run day, what happened is it auto-populated all these shots, which is really convenient.
So click on the data shots. Yeah, and then you scroll down and you see how many shots. Yeah. You can edit that.
So if you decide, oh, there's a shot that you know had a disruption or it didn't break down, you get rid of it here. That's also why I added that IP had to be bigger than 0.8 megaamps to auto reject those ones as well. So let's do plot all. Do a plot single 1D scatter. So rather than looking at every single shot, every single variable, we're just going to look at power and BetaN for a bunch of the shots. So again, you can see the relationship between power and BetaN here at a variety of shots during that.
And it rolls over, huh?
Yes. Yeah, a certain power BetaN doesn't rise. Right? If you close it, can you click on group by plot mean standard deviation by shot, just above plot all 1D scatter? And then click plot single 1D scatter again. So here you can see this, all the data points. If you don't want to get rid of all, if you want to get rid of all the individual points, because if you have tons and tons of points, if someone is making it too transparent to see a trend, all of a sudden you actually lose the points in the transparency. This will plot a mean and standard deviation by shot.
Can you click on points and see what shot it is?
Yeah, you should click on one of the data points. So you can click there.
Yeah, so that tells you the shot number and the time.
And it prints it to the console, so that way you don't have to zoom in.
What about the summary ones?
The averages?
Yeah.
I'm not sure. Yeah.
Yeah.
Yeah, the shot and time.
There might be a dot behind.
There might be a dot. But I mean, of course, if you have 2 or 3 run days and you plot BetaN versus power on a 20 millisecond time base, you have tens of thousands of data points.
So one thing that's really helpful about this tool, and I know Brian and I both use this, is actually during a run day at D3D, just having it keeping refreshed and just trying to see in general trends. It's really helpful to see if you're accomplishing the goal of the experiment.
Yeah, especially because for an experiment you have certain goals, so there are certain variables that you want to see. You want to map out the space and make sure that,
or even see how the wall conditions change throughout the day. Maybe the density is slowly.
And probably you've used this tool to prepare for that experiment. So all you need to do is kind of add shots.
Yeah. Or if you prepare to explore a new parameter space, this is useful for saying, here's where we explored before. Here's where we're trying to go.
All right.
Yeah, I think it's tremendously useful, and and now you're approaching the functionality we had on TFDR, because there was there's a utility called Mingle and Locus, which does the same thing. And one thing that we did was to make a database of we did between shots transport analysis, and we made a database of the neutron and stored energy agreement, and made a plot like that for all the shots in the run day, and then we'd show it the next morning, so you could see if there were any diagnostic issues that emerged, by disagreement.
Yes, I've heard of it. So.
In principle, have that capability to do that. But
all right, with the transfer beast mode, that could be a possibility. We have Auto12 that is run between shots. Correct. So actually, I would assume that you can, because Auto12 is stored in MDSplus, in theory, all of that information is there. There's transport coefficients and so on. So.
Yeah, there's a huge amount of information here. The thing is that in the past there was not a publicly supported tool of this level of functionality here. So we took it upon ourselves to create it.
Right.
Yeah, no, this is great.
Excellent. So I think, you made it in the 15 minutes.
There's more. Yeah, there's more to be done. I mean, there's a lot of data selection and rejection, a lot of derived quantities.
And actually,
all 3 of these workflows have many options.
Well, and actually,
I
was going to say that there are full worked out tutorials.
Yes.
For I think at least the Pubfig and the database.
The database creator definitely.
So if you just go on the OMFIT website, you find the tutorials there.
Yeah, it's under just the SCOPE tutorial.
Okay. So I guess
what's next?
Yeah, next week we're gonna have UQ. That's the plan, and the week after I think is gonna be SolPS. Right. That's the plan at least.